In this video, we're going to demonstrate how to reduce your data and analyze it using the JADE software. This video assumes that you have already collected your spectrum using the data collector from the X-ray diffractometer. And now the first step is we're going to open the expert data viewer so that we can convert our file to be readable in the JADE software. So let's go ahead and open the expert data viewer. And we use this just to convert the data because this software inherently is pretty limited in its capabilities, and the JADE software has a much larger database from which we can select our spectrum results. So in the data viewer software, we're going to go to the File menu and choose Open. And we're going to open the spectrum that we have run. Notice I have a few spectrums here. I'm going to open up the copper powder sample just by double-clicking it. And here we can see several peaks that have occurred through this spectrum. And this was a copper powder, so it's going to be a pretty straightforward sample to analyze. Instead of doing all of the analysis in this software, we're going to choose the File menu and select Convert. And we're going to convert this to a .rd file. Notice you can also convert this to comma-separated value if you wish to open it in Microsoft Excel or some other program. We have the binary scan file .rd selected, so I'm going to choose Convert. And that has now converted and saved it in the exact same location as my original scan file. With that, we are finished with this program, so we'll just close it out. Now we're going to open the JADE program so that we can perform our data analysis. In the JADE program, we're going to open our scan file by selecting the File menu and choosing Read. When we tell it to choose Read, now we can see our copper powder .rd file that we converted previously. Select that and choose Open. Now we have all of our information here, our spectrum. The first thing that we might want to do before reducing this data is to remove this background. Notice how it slopes gradually from the left side to the right side, and there's also a bit of a bend to it. So let's go ahead and remove that background, and we do that by choosing the background editor, which is this icon in the middle window. So the first thing is I'm going to left click on this, and this allows me to choose the function or the polynomial that will subtract the background. Notice the dots that now exist for each one of the for the polynomial that will be used to subtract the background. If I want to add more dots or if I want to subtract more dots, I can use the scroll wheel on the mouse to decrease or increase the number of dots. Notice that as I move my scroll wheel on the mouse, much larger number of dots occur to subtract that background. So I'm going to choose, this is a pretty straightforward background to remove. I think this looks like a sufficient number. So now I go back up to the background editor icon, and I right-click on this icon now. By right-clicking, it brings up the ability to strip the background from our data. To do so, we are going to select this small icon which says Remove Background. It's the arrow that simply tells it to, I guess, take it to the base. Not exactly sure why they choose Eliminate the Background here, but we're going to select that icon, and notice that it uses that polynomial to simply correct the to remove and flatten out the background. Alright, all of this noise, a lot of this is probably caused by the glass slide that I used. I used just a regular glass slide on our data. If you want a lower noise, so for example, if you have, here I had a large amount of copper powder. If you had only a very small amount of material, you may want to use a zero background slide. By using a zero background slide, that will eliminate almost all of this background noise that we see in this area. And that will also allow you to see a much greater, or it'll allow you to see a much smaller signal from a lower density of particles. Since I had a lot of copper powder, it didn't matter, and we see these nice clear peaks. Now to analyze this, we want to the first thing we want to do is tell it approximately or what elements might exist in this sample. To do so, we're going to choose the menu called PDF. Have no clue what the acronym stands for. So we select PDF, and we're going to go down to Chemistry. When we select Chemistry, it already has several elements that are highlighted. I suggest eliminating these, and you can do that by double-clicking on each one, or if you have a large region that you want to get rid of, you can click this blue arrow button, which just simply eliminates it. And I'm going to deselect all of these. The elements that I think that might be present in this spectrum are copper and oxygen. There are probably no other ones that exist in here. Notice when I select these two, it brings up all of the chemical formulations that are in the database currently. Whenever I select these individually, notice how it gives me possible peaks for the X-ray diffraction data. So if I click this one, the copper one lines up extremely well. And in fact, it lines up exactly with where the copper peaks should be. The other element that I thought might exist would be the oxide, some type of copper oxide. So we can continue by pressing the down arrow to see if these peaks also line up with any of the data that we have collected. Notice that as I go through here, I'm not seeing any alignment other than just pure copper. And now I've reached the end of our database for copper oxide formulations. So I'll just go back to the copper, and now I want to mark this as telling the program to hold on to this value. To do so, I'll right-click on this copper formulation, and I select Overlay. By doing that, it pins it to the graph, and now we're ready to go to the next step.